Alright, so we're going to talk about solving more equations here. In this section we'll talk about something called quadratic types of equations, also radical equations, and then rational equations. These aren't necessarily all the possible types of equations and how to solve every type of equation. It's just these are some more examples of equations we might be interested in solving. So let's look at a couple examples here. So the first couple examples we're going to look at are what are referred to as quadratic type, meaning they're not quadratic equations, but they have a quadratic form. And the one we're going to start with is x to the fourth minus 4x squared plus 3 equals 0. Now this is definitely not quadratic, it's got a fourth degree here, so it's not a quadratic equation. But what we want to notice here is we have an exponent, half of that exponent, and then no exponent, no x terms. That means it's in a quadratic form. If you have an exponent, half of the exponent, and then no exponent, that's always going to be a quadratic type. And what we can do here is what you can think of this as, and I like to do that, is say, let's let t equal x squared. And it's not necessary to write this down, but then we can say, well, t squared would be the same thing as x to the fourth power. And so what we're going to do now is rewrite this equation as be t squared minus 4t plus 3 equals 0. Now, this is now a quadratic equation. And we can solve this for t using factoring, quadratic formula, whatever. This one factors here. So if we factored this, this would factor to t minus 3 t minus 1 equals 0. And of course we'd get then t is equal to 3 or 1. Now this isn't our final answer, because our final answer we want to know what x is, not what t is. But what do we know? We know that t is equal to x squared, or that plus or minus the square root of t is equal to x. And so what we get is then x is equal to, well, it would be plus or minus the square root of 3, or plus or minus the square root of 1. So x would be plus or minus the square root of 3, or plus or minus 1. And so we solved that equation. Even though it wasn't a quadratic equation, it was what was considered a quadratic type. So let's look at one more here. This one would be x to the sixth plus 3x cubed plus 2 equals 0. Now this again is another quadratic type, because you have an exponent, half that exponent, and then no exponent. So it's going to be the same idea here, except instead of letting t be x squared, this time we're going to let t be x cubed. And then we'll go ahead and solve this, and we substitute in, we'd wind up with t squared plus 3t plus 2 equals 0. And now before I go that, if t is equal to x cubed, of course we know that x is equal, now because it's an odd root, I don't get plus or minus, I just get the cube root of t as opposed to plus or minus. Alright, well then this t of course factors here, and so this would factor to t plus 2 times t plus 1, which equals 0. So t is then negative 2 or negative 1. Now remember, again, with odd roots here, negative numbers are just fine. We will get real answers as opposed to complex answers. So x would be the cube root of negative 2 or the cube root of negative 1. Now the negative can come outside of that cube, so we'd have negative cube root of 2 or negative 1, because the cube root of negative 1 is negative 1. Alright, so those are quadratic types of equations. So you convert them into a quadratic equation, and then you just solve it using regular quadratic equation techniques. The next one we're going to look at here are radical equations. And we want to solve for x, of course, but one thing we are going to be doing typically is we're going to raise both sides of an equation to the appropriate power to try and get rid of the radical. Now, in order to get rid of the radical, one thing you often want to do first, if you can, if possible, isolate the radical. And what do we mean by that? Well, let's just look at an example here, and we'll do a couple examples of this. So, the square root of 3x minus 12 equals 0. Now, one thing with these radicals, because we're looking at real solutions, not imaginary solutions for these problems, one thing we want to make sure here right away is we want to say what x is allowed to be here. Because I've got a square root there, square root of 3x, that means I'm going to want to have x being greater than or equal to 0. Because I don't want to deal with complex instances here. So we're going to isolate this. And so we have the square root of 3x is equal to 12. We just add 12 to both sides. And then this is where, okay, now we're going to square both sides. So I'll put a parenthesis, square the left-hand side, square the right-hand side. Now if you square a square root, that just gets rid of the radical. And so we get 3x is equal to 12 squared is 144. And then, of course, just divide both sides by 3, and we get that x is equal to 48. Now, the mistake people make is they want to say, oh, we need to square things all the time, like square both sides all the time. And that's a mistake here. And the reason being is this next example here. Let's look at the cube root of 2x plus 5 plus 3 equals 0. Now, just like before, we want to isolate the radical. So if we isolate this radical, we'd have cube root of 2x plus 5 equals negative 3. And now, and we'll look at another example here in a second, I have to ask myself, is it okay so far? Yes, you can get cube roots that are negative. Alright, now instead of squaring both sides, so this is why I say raise both sides of the equation to the appropriate power, I'd want to cube both sides because I'm doing a cube root. And so then this would be 2x plus 5 is what I'm left with on the left-hand side, and this would be then negative 27. And now we just finished solving this equation. Subtract 5 from both sides, and you get 2x is equal to negative 32. Divide both sides by 2, and you get x is equal to negative 16. Now, when I say we have to make sure these make sense, let's look at an example here. Let's look at the square root of x plus 4 plus 5 equals 0. So we have the square root of x plus 4 is equal to negative 5. But this right here does not make sense. Square roots don't give negative numbers. And so the answer to this would actually be no solution. Okay, but let's say you made a mistake here and you went ahead and tried to solve this here. So you have square root of x plus 4 equals negative 5, and then you'd square both sides. Even though we know there's no solution, let's say we were trying to solve it. Well, you'd get x plus 4 equals 25, and then x would equal 21. And so it looks like you get a solution, but how do you know if you're right or wrong? Well, this is where it's actually a good habit to get in to with radical equations, is always check your answer. So does your answer make sense? Well, if you plug 21 in, you have the square root of 21 plus 4, and the original problem was plus 5 equals 0. But this would be the square root of 25 plus 5 equals 0, which would be 5 plus 5 equals 0, which you would get 10 equals 0, which does not make sense, and so we would still arrive at the conclusion of no solution. And what's going on is when you square both sides, this negative is disappearing, which that's where the issue comes in. So you should get in a habit of checking your work on these radical ones. Alright, so let's look at one more radical one. This one's a little bit more challenging. We're going to have to square both sides twice. So we have square root of x minus the square root of x minus 5 equals 1. So it looks like I just want to square both sides, and that's what I am going to do here because my radicals are isolated. But the problem is the left-hand side, I have to FOIL this out or use a special product, because this is really the square root of x minus the square root of x minus 5 times the square root of x minus the square root of x minus 5, and then this is equal to 1. Okay, well if we did this and FOILed this out, you'd get x minus 2 square root of x minus 5 times the square root of x. It's like I'm forgetting something there. And then this would be a negative times a negative, so this would be plus then x minus 5 equals 1. And so what will we get here? Well, we have x plus x, so we have 2x minus 5, and then minus 2. I'll multiply that square root of x, and so we'd have x squared minus 5x, and then this is equal to 1. Now the problem is I still have a radical here. Okay, well, what am I going to need to do? Isolate the radical. So let's move everything over to the other side. And so we get, well actually I'll just move the 1 to the other side. So we have 2x minus 6 is equal to positive 2 square root of x squared minus 5x. Now I will go ahead and divide both sides by 2. I like completely isolating those radicals. So then you'd have x minus 3 is equal to the square root of x squared minus 5x. Now I'm ready to square both sides again. Squaring both sides again. Well, the left-hand side, special product, this would be x squared minus 6x plus 9. Right-hand side would be x squared minus 5x. Okay, well then subtracting x squared from both sides, you get minus 6x plus 9 is equal to minus 5x. And then I'll add 6x to both sides, and you get 9 is equal to x. Now, because I did so much squaring and everything, I want to check to see if that is a solution that works. So let's check that in the original equation. So I'll just put it off to the side here. So my original equation is that the square root of x minus the square root of x minus 5 equals 1. And so substituting 9 in, we'd have square root of 9 minus the square root of 9 minus 5 equals 1. So that would be 3. 9 minus 5 is 4, so square root of 4 is 2. 3 minus 2 is equal to 1. So that is correct. So this is my answer. Okay, So we've got one other type of equation we're going to look at solving in here, and these are solving rational equations. So if I solve a rational equation, it's very similar to what we've done before. We want to get rid of the denominators and then solve whatever the resulting equation is. So let's look here at 4 over x plus 1 minus 3 over x plus 2 and have this equaling 1. Now I want to clear out my fractions so I can solve this. And so what I like to do here is just look at the first term here, x plus 1, and then if I want to clear that out, I would multiply to get rid of that x plus 1, I'd multiply by x plus 1. But then I also have an x plus 2 in the denominator, so I'm going to have to be multiplying by x plus 2 as well. But then I'm going to just multiply, if I do it in the first term, I have to multiply everything by that. So I'd have minus 3 over x plus 1 times x plus 1 times x plus 2, and then this is equal to 1 times x plus 1 times x plus 2. Now I'm going to take a pause here and doing this multiplication. You actually have to be careful with this, because when you're multiplying through by x plus 1 and x plus 2, we don't know what x is, but we're assuming it's not 0, because if you multiply, I shouldn't say x isn't 0, this quantity x plus 1 isn't 0, or this quantity x plus 2 isn't 0. Because if one of those was 0, you'd be multiplying both sides of the equation by 0, and that just destroys the equation. So I'm going to make a little note here that x can't be -1 or -2. And that's just in case I get to the end and I have one of my solutions being -1 or -2. That would mean it would be an invalid solution. Alright, so let's continue on here. So, of course, this x plus 1 cancels with the x plus 1. This x plus 1, I'm sorry, that shouldn't be a 1, that should be a 2 right there. But that x plus 2 cancels with this x plus 2. And then we go ahead and write out what we have here. We'd have 4 times x plus 2 minus 3 times x plus 1 is equal to x plus 1 times x plus 2. Now again, I'm trying to solve this, so I need to multiply everything out, and then I'll have combined terms and see what we have. So I have 4x plus 8 minus 3x minus 3, and this would be equal to x squared plus 3x plus 2. Now this is a quadratic equation, so we'll have to eventually set it equal to 0, but I'll take this in one step. So I have 4x minus 3x, which is x, 8 minus 3, which is 5. So x plus 5 is equal to x squared plus 3x plus 2. So now we should move everything to the other side. So I have 0 is equal to x squared, and then I'd have plus 2x, and then it's going to be minus 3. And now I simply go ahead and pull out the quadratic formula, or in this case, I'm going to factor. So this is 0 would be equal to x plus 3 times x minus 1, and so we get x is equal to -3 or positive 1, which is okay, because remember up here we said that x can't be -1 or -2, and I didn't get those as answers. So x equals -3 or 1 would be my answer.